Hey everyone, I'm Mr. A, and today I want to talk with you about similar triangles. This is a really popular topic on the geometry Common Core regions, at least if you're in the state of New York like I am, and it's a topic that is going to give you easy points if you follow a couple of key steps and just work carefully. So, the things that you want to do anytime you have a similar triangle problem are draw the triangles separately. This is key. I say this over and over again in class, and I cannot tell you how many times people will still write a proportion without drawing them separately. I'll show you what I mean in a moment, but oftentimes these triangles overlap, and when that's the case, you need to draw the pictures separately so that you can mark the congruent angles. The reason we need to mark the angles is that's how you tell what sides correspond. You can't just assume that the top left side corresponds to the other top left side because the triangles might not be oriented the same way. Once you have drawn your triangles separately and marked the congruent angles so you can tell what sides correspond, then you're ready to set up a proportion. And if you get this far, chances are you're going to get the problem right, absent any silly algebraic mistakes or not reading the problem quite carefully. So let's jump right in and take a look at some problems. Every problem that I'm going to be showing you in this video comes from a New York State Common Core exam. This particular one comes from January 2019. So we've got a right triangle ABC, point D on AB, point E on CB. In this picture, the key here is that we've got a set of parallel lines, right? AC is parallel to DE. Since AC is parallel to DE, we're going to have a similar pair of triangles here. How do I know that? Well, let's think about the two triangles in this picture. You've got the little one, DEB, and the big one, ABC. Now, they both share this angle B. It is reflexive. That angle is in each triangle. How do I know that they're similar? Well, I need two pairs of congruent angles, and that's where these parallel lines come in. So you can actually use the parallel lines to see that if this angle is a right angle, this angle also has to be a right angle. That's a pair of corresponding angles. Additionally, you could look at this angle up here and this angle up here. These angles, A and, well, I can't say D, but I could say B, D, E, right? These two angles are also corresponding angles with those parallel lines. That means they're going to be congruent. So, I know that I've got a pair of similar triangles because there are two pairs of congruent angles, and in fact I have all three here, which means I'm ready for step one. Draw them separately. So I'm going to take a minute and just draw these two triangles separately. Your drawing doesn't need to be perfect. I usually don't even label the vertices, like the letters, sometimes I do. Mostly what I'll do is just draw a little triangle and a big triangle, and I'll draw them the same way they were in the picture. So DEB is this guy, DEB. ACB is going to be this guy, ACB. The reason I draw them the same way they are oriented in the picture is so that I can easily mark the angles. So here, angle A corresponds to this one here, right? In red, I've got this angle that is exactly the same in each triangle. And these are my right angles, but I don't even really need those. Two angles is enough to see what's corresponding. So now I've got my triangles drawn separately. I have marked all the congruent angles. I'm going to fill in the information here and then write a proportion, which was step 3, right? Set up my proportion. So what do I know? AB is 15. AB is this entire side. So that's the big triangle. That's 15. BC is 12. BC is the entire side of the big triangle. That's 12. EC is 7. Okay, so EC is 7. Well, that's not a side in either one of these triangles. So let's think, what can we do with that? We know that the entire side here, right, BC, is 12. So if that's 12 and this piece is 7, what does that make EB? That's right, 5. So we're just going to subtract 7 from 12 to get 5, or, what do you add to 7 to get 12? And that's going to be the side in my little triangle. So this 7 is a little bit of a distractor. Oftentimes students will set up a proportion using that 7. You don't want to do that. You want to use the sides of the triangles to create your proportion. And then finally, we're looking for the length of BD. BD is here, X. That's the little side, and the hypotenuse of the little triangle. So there we go. We've got our two triangles drawn separately. We marked all the corresponding angles so that we can see what corresponds. Now we're going to write a proportion. I always like to start my proportion with what I'm looking for. So I would say X over something is equal to something over something. And I also like to always go side to corresponding side. So since we started an x with x in this triangle, I would ask myself, what does x correspond to in the other triangle? Now, the way I know that is I look at where x is. It is in between my single and my double tick angles, the red and the blue in this case. So I go to this triangle, I find the single and the double tick angles, the red and the blue, and whatever's in between them, 15, is going to be the corresponding side to x. Now to finish the proportion, I have to go back to the first triangle. I never go in the other direction. Since I started here on the left side, I'm going to start here on the right side of my proportion. The only other number I know is 5, so that's going to be a 5. And then who does 5 correspond to? Right angle and the double tick angle is where 5 is, in between those two. I find the right angle, I find the double tick, there's 12, that's who it corresponds to. And there's my proportion. At this point, I can cross multiply and solve. This is 12x equals 75, so x is going to be equal to 6.25, right? And that's going to be choice 2 here. Okay. So notice also it wanted BD, and that's what I labeled x in the picture. I always want to do that if possible. Label the thing that they want me to find as x, because something that'll happen is if you don't label that x, if you label something else x, and then you have to add or subtract to it at the end, is often that number will be here as a choice, and it'll pull you off the problem. And in multiple choice, you'll lose all the points. So a really good trick is to always label what they want you to find as x. That way when you get your answer, you can just look for that and circle the choice. All right, let's take a look at another one, actually also from January 2019. So this one is a slightly different variety. In fact, they were nice enough to give you the triangles drawn separately, so we don't need to worry about step 1, right? Draw separately is already done. However, we're going to jump right into step 2, mark the congruent angles. So of course, I've got a pair of right angles here. Obviously, that's a pair of congruent angles in the triangle. This angle is 61, and they don't tell me this angle. But I should be able to figure that out. The three angles of the triangle have to add up to 180. So let's see, that would be 29. And oh, that's actually pretty convenient because this angle is 29. So here we go. I've got a right angle and a 29-degree angle in each triangle. That makes them similar. Just to round this out, I'm going to go ahead and mark this one 61. And that'll be my double tick angle here for 61. And now I can go to look and write a proportion. Now what's different about this problem is they've written the proportions for you. Your job is actually to find the one that is not correct. So there's really no shortcut. You're going to go through each choice one at a time and check if it's correct. So let's see over here. AB, I'm starting in the left triangle over RS. I went to the right triangle, so that's a good sign. Okay, AB is what part of this triangle? Well, it's the hypotenuse. It's in between the single and double tick side. Is RS the right side? Yes, it's also the hypotenuse. It's in between the single and the double tick side. So we're good on the left-hand side so far. What about the right-hand side? RT. Well, RT is over here. Now right away I've got a problem. Because remember, I started on the left-hand triangle and then I went to the right-hand triangle over here. RT is in the right-hand triangle. So that's no good, right? If I go to the right triangle and then AC you'll see is on the left-hand side here, I've lost my left and right symmetry in this proportion. You've got to make sure when you write a proportion that you have vertical symmetry and horizontal symmetry. If you went from the left shape to the right shape here, then you have to also go from the left shape to the right shape here. Now this is important because if you look at RT and AC, they are corresponding sides. RT is between the blue angle, single tick, and the right angle. AC is also between the blue angle, single tick, and the right angle. So those are corresponding sides, they're just not in the right order. If I wanted this to be a good proportion, these would have to be flipped over. But since I'm looking for the one that is not correct, that's going to be my answer, choice 1. Now, since this is a video to save time, I won't go through the other 3 choices. You should do that on your own to see that they are all valid. However, if you're taking the exam and you have a question where you think the answer is the first choice, do yourself a favor and check the second, third, and fourth choice as well, because if you made a silly mistake here, this is going to be your 3 chances to catch that mistake, right? If you find another one you think is incorrect, then you can kind of have a showdown and figure out which one is the right answer. So never just circle the first answer. I'm only doing that in the video. I'm very confident that's the right answer. I'd like to move on and show you some more examples. So let's take a look at this one. I'm going to do a throwback to August 2016. We'll do some more recent ones first, but this has got a nice trick that I really want to make sure you see because it illustrates the importance of these 3 steps I'm talking about. So we've got the picture, they describe it. The key piece of information here is that angle H is congruent to angle RDO. So H over here is congruent to RDO right there. Now that's one pair of angles congruent between these two triangles, but I know the triangles are similar because there's another angle that has to be congruent. Do you see which one? It's actually angle R right here, because both of these triangles have angle R in it, the very same angle R. So, step one, draw the triangles separately. Again, this does not need to be perfect, but I'm going to draw them in the same direction they're facing here, right? So here's CHR, CHR, and then this guy I'm going to draw smaller over to the side here, and that kind of looks like a right angle, but that's okay. That's my DOR, DOR. Now, because I drew them facing the same direction, it's easy for me to find the angles. So this is the blue one over here in the big triangle. Here's the blue one in the top, and the little triangles on the top. They both have the exact same angle in this corner. It's reflexive. So you can see I've got a pair of angles congruent to another pair. Those are similar triangles. So we've drawn the triangles separately. We've marked the congruent angles. Let's get all of our information into the picture here. So RD is 4, that's there. RO is 6, that's there. OH is 4, right there. What's the length of CD? So I'm looking for CD. I'm going to call that one X. All right. So in the little triangle, this is easy. I've got 6 at the bottom, 4 on the top right. So this is 6, and this is 4. What about the big triangle? Well, in the big triangle, I have to look at this entire side. That's going to be X plus 4, right? And I have to look at this entire side, which is going to be 4 plus 6, or 10. So I can fill in those two sides of my big triangle, 10 and X plus 4. Now, I'm going to tell you right now that what happens to most students if you don't draw the triangles separately is they'll say 4 over 6 equals X plus 4 over 10. And that's wrong. It's pretty convincing because it looks good over here. You got like top to bottom, and top to bottom, so it feels okay. But when we start to write the proportion, I hope you'll see what's wrong with it over here. So again, I always like to start with my variable, X plus 4 over something equals something over something. So where is X plus 4? It is in between the double tick red and the empty angle. So I go find the double tick red and the empty angle, and look what X plus 4 corresponds to. It isn't 4, it's actually 6. Do you see why it's so important to draw the triangles separately and mark those angles? This is how we make sure we don't make a mistake. So X plus 4 actually corresponds to 6 in the other triangle. Now I go back to the first triangle because I need that left-right symmetry. So since I did left triangle over right triangle, I have to go back to the left triangle for this numerator. The only other piece I know is 10, so it's 10 over. Where's the 10? In between the blue and the red. So I'm going to find the blue and the red. In between them is 4, and there's my proportion. Do be careful about this binomial. When you cross multiply, it's going to be 4 times the entire binomial, x plus 4, right, equals 60. Give yourself a favor and take the 5 extra seconds to write that out. Now you can distribute, make sure you don't miss anything. You have 4x plus 16 equals 60. I'm getting a little short on space, so I'm just going to head over here. That would mean 4x equals 44, and x is going to be 11. And since what they wanted me to find, CD, is what I labeled x, that's going to be my answer right there, 11. Okay, so that one's a favorite of mine. Let's get back to some more recent examples from some Regents exams. Here's August 2018, just this past summer. In the diagram of this triangle, we've got, again, some parallel lines. So that's a real key that you want to keep an eye out for. When you see parallel lines in a triangle, you're almost always going to have similar triangles. As long as one of the lines is parallel to a side of the triangle, you're always going to have corresponding angles, right? So this pair, for example, corresponding, that gives you one pair of angles. And then, obviously, we've got this pair here, where it's literally the same angle. You could also grab this other pair of corresponding angles, but 2 is enough. That's all I need for angle-angle triangle similarity. So I am going to draw the triangles separately. Most important step. Probably the most important. So I'm going to draw, again, just a big triangle and a little triangle facing the same direction. I'm not going to change anything around in space. That makes it easy for me to find the angles that I've marked. So this angle is the blue angle. Here's the other blue angle. My red angle that's reflexive is this one in the bottom right corner. These are the same angle. And so now I've got the triangles separate. I've got my angles marked, which are congruent. I'm going to put my information in the picture and then write my proportion. So EB, that's this guy, is 3 more than DB. Okay, so a little algebra here. If it's 3 more than dB, we're going to call dB x, and EB is x plus 3. AB is 14, that's this entire side, right, is 14. And CB is 21, that's this entire side is 21. So let's get all this information into our separate triangles now. Big triangle first, this side is 14, the other side is 21. Little triangle next, this side is x, this side is x plus 3. All right, now notice that it is asking us to find the length of AD. That's a little sneaky because notice I kind of had to label this x, so I could call this one x plus 3, but that is not what we want. We want AD. So I'm going to make a little note to myself right here in the middle of the answers, where I'm going to go circle it later, that AD, right, the thing I'm looking for, is actually 14 minus x. So anytime you've got something that you have to pay attention to at the end of a problem, it's a real good idea to just write yourself a little note and put that note somewhere where you're going to see it. So hopefully when I solve for x, if I get too excited and go to circle x, I'll see this note and it says, hey, don't forget AD is 14 minus x, and that'll give me a chance to save the problem. Because again, this is multiple choice, so you can do everything right, circle the wrong answer, you get no credit. You don't want to lose those points. So over here, I've got an x plus 3 and an x. So my preference would be to start with x plus 3 in the numerator. That's not important, but I always like to put the binomial first if I have one. So again, x plus 3 corresponds to who? Well, it's in between the blue and the red. In between the blue and the red is a 21, so x plus 3 over 21 equals, back to the right triangle, x over 14. How do I know it's 14? Because x is between the red and the empty, red and the empty. So x over 14. So I need to cross multiply here. Again, do yourself a favor and just throw a quick parenthesis around there and write it out. This is 14 times x plus 3. Why risk messing that up? So we've got 21x is 14x plus, that would be 42. And I'm running a little short on space here, so, well, I'll keep going one more line. That gives me 7x equals 42. I just took 14x away from both sides. And that means that x is 6. Now, by the way, look at choice 1. 6. They do this all the time. Is that the answer? No. The answer is 14 minus 6, right? So 14 take away 6, that's 8. That's going to be my answer. Choice 2, number 8. All right, getting some momentum going here. Let's take a look at this one. So this one's got an extra little twist thrown into it. First of all, notice that we have those parallel lines again, right? So these lines being parallel means I've got corresponding angles there. And you know, I've also got corresponding angles over here, this pair. But I just always like to grab that reflexive angle, right? So I'm going to draw my triangles separate. There's a little triangle on top. There's another larger triangle. That is the entire picture, okay? I'm going to mark the angles that correspond. So here's my blue angles in that bottom left corner. And then I've got the red angle that is reflexive up there at the top. What information do I have? Well, dB is 6.3. Okay, so this one here, 6.3. AC is 9.4. Bottom, 9.4. Find the length of DE. All right, so that's going to be my x. And let's put this over here. So the little triangle, I got 6.3 and I've got x. 6.3, x. Big triangle, I've got 9.4. 9.4, but that's it. So there's not enough information here yet, right? Well, we actually missed something in the beginning. Right up here it says that AD to DB are in the ratio 3 to 5. Right? So AD, this piece here, to DB is in the ratio 3 to 5. So what does that mean? How do I capture that ratio 3 to 5 in the picture? I can't just label them 3 and 5 because, of course, 5 doesn't equal 6.3, right? And we already know that this side is 6.3. So we need to be able to capture that ratio without actually assuming something about the length of the sides. So the way we do that is instead of a 3 and a 5, we use 3 with a variable. So I'll call it 3y since I already have an x here, and 5y up here. Right? Does that make sense? If these are in the ratio 3 to 5, then 3y to 5y is in the correct ratio, and then all we have to do is figure out what value of y makes this 6.3. All right, so that's an easy equation to solve, right? 5y equals 6.3 is literally an equation. If we solve that for y, we'll find out is 1.26. And since now we know what y is, we can figure out what this entire side is, right? Because AB, the whole side of this triangle, well, isn't that just 3y plus 5y? Right, so that's 8y. So if this is 8y, it's just 8 times 1.26. So you just grab your calculator, multiply 8 times 1.26, and you'll get 10.08, right? So that's coming from 8 y's. And now I'm ready to set up a proportion. I've got my separate triangles, all the angles are marked. So I'm going to start with x here. I've got x over something equals something over something. So let's see, x is in between the blue and the empty angle. So blue angle, empty angle, that corresponds with 9.4. I go back to the same triangle. The only other side I have is 6.3. Over, well, that's between the blue and the double tick red. Blue, double tick red, that's 10.08. That's what's going to go there. And now I'm just going to cross multiply. I got 10.08x equals 59.22. And then we divide by 10.08 and we get x is about 5. Well, actually it is exactly 5.875. Since they want it to the nearest tenth, we've got to round to that decimal place. 7 pushes that 8 up to 9, so we're going to be at 5.9. All right, moving along. Another one from August 2018. So this is like that first one where we're going to have to choose a proportion that's valid. So this, by the way, is a very classic picture that I have an entire other video about when you have an altitude to the hypotenuse of a right triangle. For our purposes, though, we're just going to do everything the same. This is a right triangle. This is an altitude, which means it is perpendicular, so those are both right angles. And now we're going to draw our 3 triangles separately. Yes, I said 3. Notice there are 3 triangles in this picture. There's that one, and the big triangle. So I'm going to draw the big triangle first. Put the right angle over there. And then I'm going to draw the other 2 best as I can facing in the same direction. All right, so here's the right angle down there. And here's the one on the other side with the right angle down there. Now, I'll go through this more slowly in the other video, but I know that these triangles are all similar because this angle is literally the same as this angle. This angle is literally the same as this angle. So check it out. These 2 triangles are similar because they both got a right angle and a double tick red. Well, that means that this third angle has to be a blue angle because they have to have the same angle since they're similar triangles. Likewise, down here, these 2 triangles are similar because they've got a right angle and a congruent blue angle. That means that this third angle must be a double tick red. So that was a little bit quick. I'll put a link in the description. I've got an entire other video on when you have an altitude to the hypotenuse of a right triangle. This picture comes up a lot on the Regents exams or the Common Core exams, so you should definitely check out that other video as well. For our purposes here, though, we don't even need to work that hard. We're just going to label these up. I'm labeling them this time because there are no lengths, right? Everything is just in terms of the letters here. So this is D, and this is D, this is A, B, and this is B, C. And we're just going to go through one at a time and see which one of these is wrong. So AD over AB, all right? AD is over here, and AB is over here. So in between the right and the blue, looking good so far. The next one is BC. Notice BC is in a completely different triangle, right? Or, well, actually, it's in this triangle as well, but that's changing the order. So remember, I went from this triangle to this one, numerator, denominator. That means I have to keep that order. I need to go back to this triangle again. So even though BC is one of the 2 triangles we're talking about, this isn't going to work. That one is no good. This time I'm looking for one that's true, so it's not 1. How about 2? AD, okay, so we're back to AD again over AB. Same start, that's looking good. This time we go to AB. All right, so we went back to the same triangle. That's a good start. Now we go to AC. So the question is, do these correspond? Well, yeah, they do, because this is the right angle, which makes this the hypotenuse. It's also between the blue and the red ticks. AC is also the hypotenuse. It's between the blue and the red ticks. So that's a valid proportion. Since these are not true, I'll just go through and talk about why. So let's see, BD over BC. All right, BD is actually one of these 2, right? There's 2 BDs, so I'm not sure which triangle we're in yet, over BC. All right, so BD over BC. Well, BC is in between the right and the red here. BD is in between the right and the red here, so that's okay, right? So we can go BD in this triangle over BC in this triangle. Now let's see, AB. All right, well, still going good. AB is over here in the right triangle. The correct triangle is what I mean by that. It's in between the blue and the red, so the next thing I need to see is in between the blue and the red from this triangle. But I don't. I instead see AD, which is actually still in this triangle. So that's a no good proportion. And then this last one, AB over BC. So AB is here. Also here, right, over BC. BC is here, and BC is here. So let's see, AB over BC here. Well, are those corresponding sides? No, right, because this is the right to the blue, and this is the red to the blue, so that's no good. AB over BC here, I can do that. I can do in one triangle two different sides. So let's see if that pans out. So leg over the other leg, like blue leg and red leg. Now BD is, let's see, one of these two triangles, okay? Now since the numerator is the blue leg over here, right, AB was the blue leg, then this is only going to work if that's also a blue leg. So DB would have to be in this triangle. In this triangle, the proportion would already be no good. So DB would have to be here, but you see the problem, where's AC? It's back in this triangle. So this one's no good. That's the only valid proportion there. Okay. I know this is kind of a long video, but hang in there because this is such an important topic. You will see 2 or 3 of these questions almost guaranteed on every Regents. So I've got 3 more that I want to do with you, and then I'm going to let you go here. Here we've got a pair of triangles. They're already drawn separately, so that's nice. We don't have to do that. It's only if they overlap that I really need to worry about separate. But that's going to move me right on to step 2. Mark the congruent angles. So they've already got some angles marked here. This one is 65. I'll go ahead and label that blue. Okay, so I got an angle right there that's 65. This angle isn't actually in the triangle, but I can find the supplement of it pretty easily, and that's going to be actually 65. So cool. That means I've got a pair of angles that correspond there, right? I need another pair of angles. You can get that one of 2 different ways. You could notice that since these are alternate interior, the fact that they're congruent makes these 2 lines parallel, which means you can grab another pair of alternate interior angles here with A and F, or you can just notice that in the middle you've got these vertical angles, right? So angle C on each side, so DCA and FCB, these are vertical angles, so they're congruent as well. And we're trying to find the length of CB, so I'm just going to go ahead and label that X. Now, here's where this one gets interesting. So I'm going to start with X, all right, write my proportion. X over something equals something over something. Now, what are most students going to do? Well, X over, you could go 9.6 or you could go 7.2. Which one do you pick? X is on the bottom, so you pick the one on the bottom, right? Well, about half the time you do. But that's not going to be correct. This is why step 2 is so important. We've got to label the angles so we can see what is congruent. Notice where X is. It's in between the blue angle and the red angle. Go to this triangle. Where is the blue angle and the red angle? Between them is 7.2. That's the side that corresponds to X. You see how easy that is to mess up if you don't label the angles? It looks like you'd go X over 9.6, but that would be incorrect. So once you get that, the rest is pretty easy. Since I started in the right triangle, I will continue with 21.6 in the right triangle here, and that is going to go over. Notice 21.6 is in between the red and the empty angle. So in between the red and the empty, that's 9.6. And there is a valid proportion. Cross multiplying here, I'm going to get 9.6x equals 155.52. That, of course, just use your calculator for. And that'll give you x is equal to about 16.2 when you solve. So I'm just going to scroll down a little, show you the choices. Here we go. 16.2 is actually choice 3. Double check that that is, in fact, CB, right? That's what we labeled x as, what they wanted. So that's going to be our answer. All right, so this is a real easy 2-point question as long as you take the time to set up the angles so you know that x goes over 7.2 and not 9.6. All right, 2 more. So this is a very classic setup. We've got a triangle with, again, a line here that is, well, actually they don't tell us that it's, oh, yep, there it is, parallel. I didn't see the symbol. So parallel to PR, which means this line is parallel to this one. So I can grab a pair of corresponding angles. I could grab another pair of corresponding angles over here, but as I mentioned earlier, I always prefer to use the one reflexive angle. So, step 1, draw the triangles separately. What are you going to do? Draw the triangles separately. Do yourself a favor and do not skip that step. I made those kind of the same size. I'd prefer if this one was bigger. I'm going to live with it though. This one's on the top and this one's below, so this will be my little triangle on the top. This will be the whole thing. I'm going to mark my angles. Since I didn't change the way they are facing, it's easy to do that. The red angle is just in the top. The blue angle is in the bottom right. So these are the blue angles. Okay, what do I know? My little triangle has got a side that's 5, and that's it. So I'll put the 5 there. My big triangle, well, this whole side is 7. So that's 7. And now let's see, what else do I know? Oh, I didn't see this 5 over here. Okay, so I've got a little 5 over here, but notice that is just this piece. It is not the entire side of the big triangle, and it is not at all the side in the little triangle. I'm looking for QR, so let's label QR X. So the whole thing is X. That's going to be the side in the big triangle, X. Then what do I label this, QT? So you could call it Y, because you don't know what it is, but then you've got 2 variables. That's going to make things harder than they need to be. So what could I call this where I'm still going to use X? Well, if this whole side is X, and the part that I don't want, sorry, is 5, well then isn't this just going to be X take away 5? Hopefully that makes sense. That means the side in the little triangle over here is X take away 5. Now I'm ready to go ahead and set up my proportion. So I'll start with the binomial, since I have a binomial and the monomial x. X minus 5 over something equals something over something. So x minus 5 is in between the red and the blue. In between the red and the blue is x. Go back to the first triangle. Remember, you need that symmetry. Top triangle over bottom triangle is how we did this. So we're going to go top triangle over bottom triangle again. 5 is the only other thing I have. 5 is in between the red and the empty angle. So 7 is between the red and the empty angle here. There's my proportion. Again, this is a binomial. You want to be careful about that. It's easy to just do 7x minus 5. That would not be correct. It's 7 times x minus 5. Do yourself a favor. Write out that one extra line so you can distribute right in front of you. 7x minus 35 equals 5x. So let's see, I'll take 5x away from both sides. That's 2x. I'll add 35 to both sides. That is going to give me x equals 17.5. Now, since I labeled x this entire side, right, which is what they wanted, QR, I'm good to go. There's my answer, 17.5. This is why I always like to label the thing they want with x. I could have made this side x, and then I wouldn't have had to do this x minus 5 deal, but then at the end I would have to remember to add this 5 back. I would have gotten 12.5. So it's always a good idea to make the thing they want just your variable. That way you have one less thing to think about. Okay, one last problem that I want to go through with you here. Same setup. We've got a triangle with a line parallel to one of the sides. So this is parallel to this, which means I can grab myself a set of corresponding angles there. Again, I have that reflexive angle at the top. I'm going to draw my triangles separately. I will make sure the bigger one is bigger this time. There we go. I'm going to mark my angles. Up at the top, I've got this red angle, which is reflexive. It's the same in both triangles. And then on the bottom right, I've got this congruent double tick blue angle. What do I know about these triangles? The little guy has a 15. The big guy has a 40 on the bottom. And over here, the big guy is this whole side, right? 9 plus 15, so that's 24. That will go over here. And then what else do we know, or what are we looking for? The length of DE is what we want. So DE right here, I'm going to label that X. That is the side of my little triangle. So that's going to be X right there. Now let me just talk about how easy it is to mess this up again if you don't make the two triangles separate. Over here, what a lot of students will do is they'll see the x in the 40 and the 15 in the 9, and they'll say, hey, x over 40 equals 15 over 9. But that's not true. Now, there's nothing wrong with x over 40. If you look over here, x does in fact correspond with 40. So I can start my proportion in that way, x over 40 equals what over what. But here's the deal. Since x is a side of this little triangle, I have to go back to this little triangle. And what I want up there is actually 15, not... Well, sorry, the 15 is what I would have gotten anyway, but the 15 corresponds to the 24, the entire side of the big triangle. If you put 15 over 9, you'll get a different ratio. So 15 over 24 should be pretty obvious with this set of triangles, but if you're working on the original picture, about half the time, half the people are going to put 15 over 9, and that's just not correct. So we're going to cross multiply, and we're going to get 24x equals 600. Divide by 24 on both sides, you get x equals 25. And again, since what they wanted, DE, is the thing that I labeled x, that's going to be my answer, 25 right there. Okay, now I know I said that was the last one, but I do just want to plug that other video again because this comes up so often where you have a right triangle with an altitude to the hypotenuse. I will put a link in the description. I've got an entire video just on that topic, and I would strongly recommend that you check it out because it's going to be on, again, pretty much every single Regents. Somewhere on there you're going to see this topic. And this is just more similar triangles, but there's enough going on here that it's worthy of its own video. Okay, I hope you enjoyed that video. I hope you found it helpful. If you did, a like and a subscribe is really appreciated. If you have any questions, feel free to leave a comment. If you're in my class, shoot me an email or send me a reminder, and I'll be happy to help you out. Have a great day. Thanks for watching.